We'll take a couple minutes here and talk about gravitational potential energy. So this is the energy associated with the gravitational pull. So if I've got an object close to the Earth, it's being pulled on by gravity, and so there's an energy associated with that. So properties, as with all energies and energy systems, gravitational potential energy is a scalar. You'll see a couple different variables that can be used here. You can see GPE. That's probably what you'll see most common because it's pretty straightforward. You will also sometimes see U with a lowercase g. And this U is just the variable that we use in physics for potential energy. So if you see a U, it probably means potential energy. The units, like with all energy, it's joules, which is also 1 Newton meter, which is also equal to 1 kilogram meter squared per second squared. The equation for gravitational potential energy is going to be for the change is mg delta h. So the constant you can see here is mg, which you'll also recognize as the weight of the object. And then the indicator is the height. So if you change the height, distance from the Earth, that will be your indicator. So for an example, for a given building, assume the vertical distance between each floor is 4 meters. How much gravitational potential energy is gained by a 10 kilogram something that is moved from the ground to the first floor? How much is gained from the first to the fifth? What about from the fifth back to the third? So delta UG is equal to mg delta h. So in the first case, we have the mass of 10 kilograms times g of 9.8 meters per second squared times a change in height of how many floors from the ground to the first floor. So 1 floor at 4 meters each. And that's going to give you approximately 400 newtons, give or take. For the second part, to move from the first to the fifth, we're going to have delta UG is equal to same 10 kilograms, same g of 9.8 meters per second squared. But this time we go from first to second to third to fourth to fifth. So we have 4 floors difference times 4 meters each. And we're going to get approximately 1,600 newtons in that case. And then lastly, we have delta, and actually, let me write this a little more properly. This should actually be 4 meters minus 0 meters, because we're starting on the ground. I'm getting sloppy and getting ahead of myself. This should be 16 meters, sorry, not 16. This should be 20 meters minus 4 meters. 20 meters for being on the 5th floor, 4 meters for starting on the 4th floor, final height minus initial height. And this will be important for this next one you'll see. Now, if you wanted to just calculate the change and do the signs yourself, that's fine, but I want to be a little more explicit and better with my math here. So if we start on the 5th floor, if we end on the 3rd floor, that will be 3 times 4 meters as my final height, and I'll subtract 5 times 4 meters as my initial height. And you'll notice that this ends up giving us a negative value, so approximately negative 12 minus 20, so negative 8, approximately negative 800 newtons. These shouldn't be newtons, these should all be joules, sorry. Joules, I'm getting sloppy here, joules and joules. So we have in each of these cases about 1,600 joules for part B, about 400 joules for part A, and about negative 800 joules for part C. As with all energy systems, we can only calculate the change. However, if you're given an absolute amount of gravitational potential energy, This means it's being compared to a standard reference point, and that's usually either the starting height or ground level. Sometimes you just kind of have to tell from context of the problem. So they might say like an object is dropped off a cliff. At 10 seconds, it has negative something sub, joules of energy. That means they're comparing to where it started. Or in this example, if we said something has a certain amount of energy, we'd be comparing it to that ground floor. It's a little weird, but with practice, you'll pick up on kind of the nuances there. And if you're ever unsure, ask me and I'll be happy to clarify.